So this problem reads, I want to make a bouquet of 6 flowers. I have 7 roses, 5 tulips, 5 daffodils, and 3 hydrangea to choose from. What is the probability that my bouquet will contain at least 1 rose? Well, before we even approach this problem, let's discuss what the sample space is so we can get that out of the way. So in this problem, what are we doing? Well, we have 20 different flowers to choose from, and we're going to pick 6 to make a bouquet. So our sample space is just 20, choose 6. That's the generic idea of what's happening in this problem. Now, specifically, we want to know the probability of at least 1 rose, meaning greater than or equal to 1 rose. Now, if you've looked at this sort of problem before, you would realize this means that we need to look at a whole bunch of different possibilities. We would need the possibility that there's 1 rose, then we'd need the possibility of 2 roses, 3 roses, 4 roses, 5 roses, and 6 roses. Now, that's really a pain to figure out. You're going to have to figure out each one of those probabilities separately, add them together in order to get your answer. So there is another option here and another way to go about doing this problem, and that actually is to use the complement rule, or to use the complement of at least 1 rose. Well, if we go back to our list here, where we've listed out all the different possibilities, the only other option, as I'm adding in here in red, is the possibility that there are no roses, right? So we've got no roses, 1 rose, 2 roses, 3, 4, 5, or 6. Those are the only ways to get roses in our bouquet. And the probability, the original probability, actually uses up all 6 of them. So the complement of at least 1 rose would be what we are left with here, which is the probability of no roses. So what that means is if we can find the probability of 0 roses, we can just subtract that from 1, because that's our complement rule, and it will give us the probability that we need. That is a much easier way to go about solving this problem. So let's take a look at the probability that there are no roses in our bouquet. So we already know what our denominator is. We said that is our sample space, which is choosing 6 out of the 20 flowers. But if we want to have no roses, that means from all the flowers that we actually have to cross roses off of the possible flowers that we're choosing from. So all we have left to choose are from the tulips, the daffodils, and the hydrangea, which means we have 13 to choose from, and we're going to choose 6. And so once we get this will be the probability of getting no roses. Once we have that, we can just go ahead and subtract it from 1. So let's go ahead and compute this and see what we've got. So when we do the calculations, the combination of 13 things taken 6 at a time is 1,716, and the combination of 20 things taken 6 at a time is 38,760. When I divide these and I round it, I get 0.0443, and then when I subtract that from 1, I get 0.9557, which means that I have a 95% chance that my bouquet will contain at least 1 rose. So again, to recap, because it's too difficult in this problem, it's not that it's difficult, it's just very time consuming to consider all of the possibilities where you might include 1 rose, 2 roses, 3 roses, etc. It's actually easier to use the complement of 1 rose, or the opposite of at least 1 rose, which is no roses, and subtract that from 1.